Let's get solving the system of equations with elimination. So with elimination, by the way, this sets up best for elimination because both equations are already in standard form, kind of. So the y's are lined up, the x's are lined up, and so are the constants, which means that we should be able to eliminate them pretty quick, especially because the coefficients of y's are already opposites. The coefficient of the y for the first equation is a positive 2. The coefficient of y in the second equation is negative 2. So they're already opposites. So if I were to take these and combine them, I can zero out the y's. Okay, so this does zero out the y's, which is kind of as planned. We didn't force that to happen, but it's good for us to zero that out. Now we will combine the x's. That's 3x's minus 2x's, which is 1x's. And then this would equal, that would be 14 minus 10, which is 4. Now, since the coefficient of x is already a 1, this means we have already solved for an x value in our ordered pair. And that x value we found is 4. So I put the x in as 4, and all I got to do now is solve for the corresponding y value. So to do that, I'm going to take the top equation, but you could use the bottom one if you'd like. So the top equation, 2y plus 3x equals 14. And we'll replace the x with 4. So the x then is 4, and then I solve this equation. So first up, distribution, 3 times 4 is 12, that's positive 12. Now it's 2y plus 12 equals 14. Now solving this equation for y's, I'll keep my y's on the left, numbers on the right. So the 2y is okay, but the 12 doesn't have y, so it has to be zeroed out. Minus 12 on both sides. So I can drop my 2y's now. 12 minus 12 zeros out, that was part of the plan. 14 minus 12 is 2. And then last up here, to make this coefficient of y a phantom 1, I simply divide both sides by 2, coefficient of y. Now on the right side, that's 2 divided by 2, which is 1. I need that 1, but that means that the y should be a 1. Last thing I need to do is just double check. Okay, so the y is 1, the x is 4. So that'd be 2 times 1 plus 3 times 4. That's 2 plus 12, which is 14. And at least the first equation checks off. The second equation, negative 2 times 4 minus, no, I did that backwards. Negative 2 times 1 minus 2 times 4. So that'd be negative 2 minus 8, which would be negative 10. And the second equation checks off as well. So that means we did, in fact, find the solution to this system of equations as 4, 1. I can solve systems of equations with any method. So what they're going to do today, they're just going to give us a bunch of systems, and then we have to solve with whatever method we want to use. So you can use elimination if you'd like. You can graph, or you can use substitution. But today we're going to kind of throw in a fourth method, kind of, and then you can see if you like that better, or you can skip it. Take 30 seconds, copy this down, then we'll get started. So when we look at a system of equations, and again, they're not going to tell us which specific method to use. Usually it'll become pretty obvious which one we should use, just depending on the format of the two equations. So if one of the equations here at the top, doesn't matter if it's x equals or y equals. If at least one of them is like this, then usually we'll use substitution to solve it. Now, if both of them are like y equals, then you could use graphing. And again, even though this may be like the best method to choose, it's just an opinion that it's the best method. So if you're committed to graphing, you can graph all the time. Or if you want to use substitution all the time, that's fine, or even elimination. But just like we saw in the bell work, if you're going to use elimination, then usually both equations are in standard form like this one, ax plus by equals c, something like that. So these are things that you're going to look out for. It may take some time to really figure out which one you're going to use. So take your time. Okay? Look at the actual equations, see what they say. But if you see these formats, then usually these are going to work. Okay? So, by the way, if you're going to use graphing, then use the calculator because that's what it's there for. So just right off the bat, looking at this system right here, some of you'd be like, I want to manipulate these equations into y equals format so that you can graph it, which would be fine. Some of you may want to manipulate one of the equations into y equals or x equals, which would then allow you to use substitution. But for me, I'm going to take both these equations, since they're already in the same format, which is standard form. I'm going to take both of them, and I'm going to solve both of them with elimination. Okay, so just the way that I've lined these up, stacked, we've got the x's, then the y's, and then we've got the constants. So if I can just get one of these two to eliminate with opposite coefficients, then we can solve that hopefully fairly quickly. So it doesn't matter which one you choose to eliminate. You should always do a little analysis with your equations if you're going to use elimination. I look at these and I see like the x's, neither of these are multiples of each other. Same with the y's, so I can't eliminate one or the other easily, which means that it doesn't matter which one I choose. I am going to choose to eliminate the x's, okay? So if I want to eliminate the x's, then I'm just going to take the opposite coefficient, the other coefficient, and multiply it into the other equation. So this means I'm going to take the top equation here. Its coefficient is a 4. The bottom equation has a coefficient of x that is 7. So I'm going to multiply this equation by 7. All right? Now again, we'll make them opposites. Right now they're not opposites. But this will at least give me a new equation to work with the new coefficient of x. So first off, I would distribute, which is really principles of equality, because I'm going to apply the 7 multiplied to all the terms. So that's 7 times 4x's, which is 28x's. Then I've got 7 times 5y's, which is positive 35y's. And then also, this would equal 7 times 6, which is 42. So this is a new equation here in red, but it's actually the same equation, we've just scaled it with principles of equality. Now, I've chosen to eliminate the x's. Right now, I've got a 28x. I need the next coefficient of x to be a negative 28x after we've worked with the second equation right here. So we look at this bottom equation. I know I can get 28 out of 7 simply by multiplying it by 4. The problem with this is that would be 4 times 7x's, which would be positive 28x's. So to make it an opposite, being a negative 28x, I'm going to have to multiply that by negative 4 instead. So this multiplication now, negative 4 times 7x's, will now give me the negative 28x's, which I'm looking for. This will eliminate the x's, but now we've got to multiply the negative 4 by all the other terms. So that's negative 4 times 9y's, which would be negative 36y's. And then this would equal, that's going to be negative 4 times 12, which is negative 48. All right, so the way we've done this, we've kind of forced the x coefficients to be opposites. We have a negative 28x and a positive 28x. And now if I were to take these two equations and combine them, the x's will eliminate, which is part of the plan. 28x's minus 28x's, there's our elimination of the x's. 35y's minus 36y's would be negative 1y, and we do need to see the negative. 42 minus 48 is going to be negative 6. So this is pretty close to being solved for y, but the last thing I need is a coefficient of y that's a phantom 1. I just want to see this as y equals. So I'm going to take that negative 1 and divide it by itself. But if I do it to one side, I got to do it to the other side also. So that's negative 1 divided by negative 1, which is phantom 1. Negative 6 divided by negative 1 is now positive 6. Oh, that was really fun. But as usual with systems, we need both an x and a y value, and right now we only have a y value of 6. So in our ordered pair, we have a y value that's 6. That's great, but we now need the x value. So it doesn't matter which equation we choose. I'm going to choose the one on the left, which is 4x plus 5y, and this equals 6. Okay, so this was the first equation. 4x plus 5y equals 6. But over here, we found the y value that's 6. And so I'm going to take the y in this equation and replace it with 6. And then I will solve for what should be the corresponding x value. All right, so solving equation, first we got some distribution. 5 times 6, which is positive 30. Now we got 4x plus 30 equals 6. Next principle of equality, I'll keep my x's on the left, numbers on the right. So the 30 does not have an x, so it has to zero out. So minus 30 from both sides. Okay, so that's going to zero out. Now we'll drop my 4x, which equals 6 minus 30. All right, 6 minus 30, this is going to be much better. This is going to be negative 24. Okay, so this is going to work out really good, actually, in the end here. Because the last thing we need is a coefficient of x that's a phantom 1. So divide both sides by 4, and this will give us negative 6. Okay, so this is our x value, negative 6. That should work. Okay, so it looks like all our work looks pretty good, except I had made a mistake right there. But now we can check both equations, right? So this would be 4 times negative 6 plus 5 times 6. That's negative 24 plus 30, which is 6. So that first equation does check off. The second equation, 7 times negative 6 plus 9 times 6, that'd be negative 42 plus 54. Yeah, that's going to be 12. So the second equation checks off, and now we know we have found the solution. So if I was to do this on a calculator, now we just solved the problem, right? And we now know that the solution for us, up here we had an x and then a y value. We found that the x value was negative 6 and the y value is 6. So right now we're going to put this into the calculator, and then the calculator is going to show us, hey, your x is negative 6 and y is 6. And it's without having to do any of the matching of the coefficients or eliminating anything. We just push this into the calculator, and then we're good. So first thing we have to do is actually enter the two equations into the calculator. Now, to do this, we're going to use what's called the matrix mode, or the matrix function of the calculator. You'll see right above the x to the power of 1 button, it says matrix, okay? So we are looking for matrices, or matrices, and that is 3 buttons down from the second button. So you got alpha, math, and then right below that is x to the power of 1 on the upper left side of the calculator, okay? Now you got to push second in order to access matrix, so I push second x to the power of negative 1. When I do that, at the top of the calculator, you're going to see these 3 options. With these 3 options, what we got to do is get into edit, okay? Because we actually have to enter values into one of the matrices. So that's why we push over. That's going to get us to edit. So you'll see this highlighted, and then you'll see something like 1A, 2B, 3C, and then it should go all the way down to, I think, 7G or something like that. Okay. We only want A. So right now at the top, you should see something like this, 1, and then it'll say A like this, and it's highlighted. You're just going to push enter. So I push enter right there. Okay, so I'm going to push enter because I want to edit matrix A. Right now, when I do that at the very top, it's going to say something like matrix A. So after pushing enter, I now see this at the top, and it's blinking right here because it wants to know the size of the matrix. So the size of the matrix, the first number I'm going to tell the calculator how many equations I have, and that's 2. That's why we're going to push 2 right there. And when I enter that in, it will now show 2. Okay, so I would push 2. Then I push over, and then it's going to go into this after the x. And it's asking how many spaces or columns you have. Well, up here at the top, you can see that you got an x column, a y column, and then constants. That's what I need. I need 1, 2, 3 columns in this matrix. So I would push 3. Now I would push down. So when you push down, you're going to see it's got 2 set of square brackets like this. If they're not empty, that's okay. but we're going to put stuff in there either way. We're going to put the stuff from both equations. So I'm going to start, I'm going to call this my red equation here first. That's 4x plus 5y equals 6. So I got three numbers. I don't need to enter any x's. I don't need to enter any plus signs or equal signs. If I had a minus, it would be negative though. But I got positive 4, positive 5, and positive 6. I'm going to enter each of those numbers in, but after I put them in, I'm going to have to push enter for each one. So I would push 4, and you'll see 4 come up right here. Now I push enter, and it goes into the middle spot right here. Okay, so my next number would be 5. That's the coefficient. So I push 5, enter, and you'll see a 5 show up, but then the cursor goes to the next slot, and that's where I got to put this constant in, 6. So I push 6, enter, and then it gives me a 6 there, and then it goes to this slot. So that means this is the first equation right there. The second equation is this second set. It's just 7, 9, and 12. So I push 7, and then 7 shows up. Enter, it goes to the next slot. And then I push a 9, enter, and then I push the 12. And then this means that I have now entered both equations into the calculator. This row is 4x plus 5y equals 6. And the calculator knows it. It's just skipping all the extra garbage. And then the second equation is right here, 7x plus 9y equals 12, which is the two equations right there. In fact, I'll change the color so it kind of coordinates right there. We'll make this one green, I guess. All right, now if any of these were negative or minus, I'd have to put them in as negatives. Not the minus button, you use the negative button for those. But the calculator now knows the two equations that I have that I would like it to solve for. Okay, so we're done with this entering in the edit mode of the matrix function of the calculator. What I now need is to do the RREF function of the calculator. And even though you guys don't want to know this, it stands for reduced row echelon form, and math nerds everywhere will know it, but it's still pretty nerdy. Okay, so I got to get out of this mode though, so I'm going to push second mode. If you look right above the mode button, which is one button to the right of second, it's going to say mode, and then above it it's going to say quit. Yeah, I'm done with the editing function, so I'm going to quit that. So that's why I'm pushing second mode. But I'm going to go back into the matrix function, and I'm going to look for RREF. So I'm going to push second x to the power of 1. Again, that's going to access the matrix function. And now I'm back at this stuff right here, right? So I got name, math, and edit. Okay, so this is what I'm seeing at the top. I've got to go to math. So I'm going to push over to the right one, and then it's going to highlight math. Now I've got to look for reduced row echelon form, RREF. Now to get to that, you're going to push up, 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 up. That's five ups right there. Because it's got a lot of options for your matrices. So what you'll see on the calculator, and this is the one you're looking for, it's going to show B, colon, and it's going to say R, R, E, F, parentheses. That's the one that we want. Once you find it, you're just going to push enter. Okay? If you push enter, it's going to take you back to the home screen here, and then it's going to say on the screen, it's just going to show RREF. So RREF with a parentheses there, okay? So the calculator is pretty much telling you, hey, I'm ready to solve the system of equations for you. You just got to tell me which system you have. Well, we remember up here that we entered it in as matrix A, so we've just got to say use matrix A. All right? So, but that took care of the second part. We're telling the calculator, please solve the system with this function. Now we just got to tell it which system we're going to use. We're going to go back to second x to the power of -1. Second x to the power of -1. And right now it will show, again, name, math, and edit. Well, we just want the name A. So we're choosing, since this is the system that we put in, A, that's the one we're going to choose. Now when I push enter on this, then on the home screen, so that's the first enter I have, on the home screen you're going to see it put in system A. Now you can close that parentheses right there, but I'm just going to push enter, and here's what the calculator is going to show me. All right. So after I push enter the second time, then the calculator is going to give me some square brackets like this. It's going to say 1, 0, -6, and it's going to say 0, 1, 6. Well, how do I know that? Well, remember when we put the matrix in, or the equations in, we had an x column, a y column, and then a constants column. It's going to work down here as well. You've got a x column, y column, and then a numbers column. Okay, it's an x plus y equals equations, which means that the first row is telling you that you have one x, you don't have any y's, but that one x is going to equal -6. That's what this means. It's telling you that x equals -6 right there, just like we found in the original problem when we solved it. The second one, it's saying your y right there, because there are no x's, there's no x's, but you have a y right here that is +6. So that's telling us that the y value is +6, which it was up here. So this is an ordered pair. It's just giving you an ordered pair in a different format, but it means exactly the same thing. Okay, this is RREF right there, but it's a different format. So you can use a calculator to do this. What surprises me is that I've seen some of you guys on your phones before, and you can be on your phones and type fast enough where there's actual smoke coming out your fingers. But then when we're like, hey, let's solve an equation, let's solve a system with the calculator, and there's really not much button pressing, you're like, I can't do it. Like, what the crap? How is that possible that you can type that fast on your phone, but when it comes to calculators, I'm not going to do it, whatever. Here's another system. 4x plus y equals 42 and y equals x plus 7. Try this one out. See how you do, then we'll go over it. So on this one, I've got two equations, but the problem is right now the two equations are in different formats. You got 4x plus y equals 42. That's standard form. The second equation, y equals x plus 7, not standard form. This is slope-intercept form. So what you can do, if you wanted to use the calculator on this one, let's say you wanted a graph, then you'd have to subtract 4x from both sides on this equation, and then you can put both equations into the y equals function of the calculator and graph it. And then you can use the intersection mode or function of the calculator to figure out where they intersect on your graph. Whatever. On the other hand, if you wanted to use the calculator method like we did on that last problem, then you would have to subtract x from both sides on this one in order to make both equations the same format, okay? Which would be standard form. But the way this sets up, I would use substitution method because, well, I'm a math nerd. And I like to use the colors, which makes it pretty. So that's what I'm going to do here. I see one of the equations is y equals something. I don't really care what it is. It's x plus 7. I don't really care about that, though. It's just x plus 7. So that means I'm going to take this y over here, the x plus 7, and I'm going to replace it into this y here from the 4x plus y equals 42. And I'm going to replace this y with this x plus 7 stuff. So instead of showing it as y, I'm now going to show it as x plus 7. Okay, so I've replaced that y with x plus 7, and now I would have 4x plus that stuff equals 42. Now, if there was any distribution, I would keep the parentheses, but there isn't, so I'm just going to get rid of those and then work from there. You can still distribute a positive 1. It's just not going to change anything. And now I would see this as 1x because the next step is to combine like terms because there was no real distribution. That's 4x's plus 1x's, which is 5x's. Now I've got 5x plus 7 equals 42. So a two-step equation. Only two principles of equality should be able to solve this. So I'm going to keep my x's on the left and the numbers on the right. So the 5x is okay, but the plus 7 in purple right there, it's on the wrong side because it does not have an x. So I'm going to have to subtract 7 from both sides. So minus 7. Again, if I do it to one side, I got to do the other side. So this then, from left to right, allows me to drop my 5x's there. which should equal, because 7 minus 7 is 0, which was part of the plan. 42 minus 7 is 35. And now that we have this, the last thing I need from the x is a phantom 1x. So to make that 5 a phantom 1, I'll just divide both sides by it. And I get x is 7. All right, so if x is 7, let's make an ordered pair, which should be our solution. Remember, it's an x then a y value, but the x value is 7. So if the x value is 7, let's go back to, I'm going to use the second equation because this will solve for y pretty quick. Y equals x plus 7. But we're pretty sure we just solved for x as 7. So I replace the x with 7, and I solve this for y. This is going to give me y equals 7 plus 7, which is 14. So it appears that the y value is 14. But let's just double check with this first equation. I know 7 plus 7 is 14, so I can give my first or the second equation here a check mark. That one should be true. But the second one, this would be 4 times 7, which is 28, plus 14. Yeah, that's 42. So that one checks off, and we did find the solution. We're going to see word problems on this assignment too, so let's read this one. And again, just in doing these types of problems, you may have to read and reread these several times. And since we love reading so much, it's going to be so fun. Hopefully we like reading more than math, but either way. A small town has 2 local high schools. High School A currently has 500 students and is projected to grow by 55 students each year. High School B currently has 650 students and is projected to grow by 30 students each year. Let A represent the number of students in High School A in T years, and let B represent the number of students in High School B after T years. So they're using the same variable here, just a quick note, T years. And then High School B also with T years, okay? So I assume they're going to want to see how many years it's going to take for the 2 schools to have the same number of people. But let's read the rest of this. Write an equation for each situation. So we have High School A and B. Write an equation for both of those in terms of T, and determine how many years T, the number of students in both high schools, would be the same. There we go. So that's where our principles of our systems of equations will come into play for us. So I'm going to start by writing equations for both schools. And I'm going to do High School A in red. Okay, but what we do know is that T is some number of years. They said it here, here, and also up here as well. T will automatically represent number of years. So High School A in red. Okay, so up here it says High School A currently has 500 students. That's what I'm going to start with. So I'm going to take those 500 students that it currently has. It's projected to grow by 55 students every year. So this is how many students, 500, that it has. But then it's going to grow some number of students as well. And that appears to be 55 students every year. Now, this 55 right there would be for only 1 year. But what we're going to have is many years. We don't know how many years it's going to be. So that's why we use the variable T. We're going to take those two, how much it has and how much it will grow, and add those together to figure out how many students are in High School A. That is our first equation for High School A. High School B, we'll do in purple. So there's High School B. Oh, and they said to let B represent High School B and A represent High School A. That's why I'm using these. So High School B will be represented by B. And what do they say about High School B? Again, you have two different values. You have how many students the school has and how much it's going to grow by. So High School B, let's see, it says it has currently 650 students. So it currently has the 650. And then it's going to grow by 30 students each year. So it'll grow by 30 right there. Now this 30 is how much it will grow every year. That 30 represents 1 year. To figure out how many it has after a certain number of years, we'll have to multiply by T, which we don't know how many years that will be. If we add those two together, that's how many students are in High School B. So we have the 2 equations, and that's our first part, right? Write an equation for each situation in terms of T. We did it. The next thing we got to do, though, is figure out when the number of students in high schools would be the same. So here's what we're going to do. I'm going to rewrite a new equation. We have high school A students, and then we're going to compare that to high school B students. What we want to know is when they are the same, and the same would indicate that the number of students in both high schools would be equal. Okay, so I just got an equal sign between A and B there. A being the number of students in high school A, B is the number of students in high school B. Well, we have equations to represent those, right? A equals 500 plus 55t. So instead of the A, I'm going to say what it equals. This is substitution, by the way. It's 500 plus 55t. Now this should equal how many students are in high school B, which it says down here in the bottom left. It says there's 650 students, but we're going to add 30 students every year for t number of years. So the good news for us, the way this sets up, the way we had set it up, is that the t's, it's the same t on both. This is going to be the same number of years, how long it will take for the two schools to equal then the number of students. So from here then, all we're going to do is solve this equation. And no distribution, no combining like terms. So we're right into principles of equality. T's on the left, numbers on the right. You could switch those if you'd like, but it doesn't matter. So again, let's go through each term. 500, it's on the t side, but it doesn't have a t, so I'm going to have to zero that out. So minus 500. If I do it to one side, I'll have to do it to the other side. So this will zero that out, and then I can drop my 55 t's. And then this would equal 650 minus 500 is 150. And then we'll add the 30 t's. Next up, the 55t is okay because it's on the t side. The 150 is okay because it's on the number side, but the 30t is on the number side, but it has a t. So we're going to have to zero that out as well. So I'm going to have to subtract 30 t's from the right, but if I do it to the right, I've got to do it to the left as well. 55 t's minus 30 t's appears to be 25 t's, and this would equal 150. Right, we dropped that, and then yeah, we zeroed out the 30 t's right there. The last thing I got to do to solve for my t, phantom 1t, is divide both sides by 25. And 150 divided by 25 should be 6. Now, since we're doing this by hand, the answer is actually not 6. Because it's a word problem, we have to label the answer. And t equals 6. That would be 6 years. So based on the projections that we have there in the beginning, it's going to take 6 years for high school A and high school B to have the same number of students. Now, we're not going to solve this, but if we know it's going to take 6 years, you can figure out how many students that would be, and that would actually check the answer. I guess this one's easier. 180, so 830. So it looks like there'd be about 830 students. So either way. On a snow day, you make 2 snowmen in your backyard. Snowman A was built to a height of 33 inches, and snowman B was built to a height of 45 inches. The next day, the temperature increased, and both snowmen began to melt. At sunrise, snowman A's height decreased by 6 inches per hour, and snowman B's height decreased by 9 inches per hour. Let A represent the height of snowman A t hours after sunrise, and let B represent the height of snowman B t hours after sunrise. So we're going to make a graph for this, graph each function, and determine which snowman is taller after 3 hours. Yesterday when I did this with the class, I solved for when they're the same height, which you can do, but that's not what this is asking for. It's saying, how tall are they after 3 hours? Okay, but we got to put this on the graph. So let's go to both of these snowmen. Now I'm going to start with snowman A, and it says you should use A for the height of snowman A. Where did it say that? It says snowman A. Oh, there it is. Let A represent the height of snowman A. Boom. So that's my A that I have there at the top. Okay? So A is the height of snowman A. Well, how tall is Snowman A? Well, how tall is Snowman A? I'm going to say this is my starting value for this. So it starts at some height. But then it's also going to melt. Okay? So, how tall is it? First thing in the morning here, it says Snowman A is 33 inches tall. That's how much it was when they built it. So it starts at 33 inches. There's my 33. Okay, so how much is it melting? There it is. Snowman's A height decreases by 6 inches per hour. So from those 33 inches, it's decreasing, so I need to know that that's going to be minus sign by 6 inches every hour. Now, again, this minus 6 is only for 1 hour. It then says, if you're going to use T is going to, and this is for both, T is hours after sunrise for both snowmen. So, we're going to take away 6 inches every hour. We just don't know how many hours this is going to take place. We multiply it by T. And that's the equation for Snowman A. How about Snowman B? So Snowman B, it says Snowman B, I guess first off it says let B be the height of Snowman B. So that's what I will do. So it's going to be B equals, and it has the same values. How much did it start at? So at the top it says Snowman B was built to 45 inches tall. So I'm going to put 45 inches in there. That's how much it's going to start at. This one also is melting. So Snowman B is decreasing by 9 inches per hour. So it's not plus this time, it's now minus. We're going to take 9 inches off every hour. But that's only for 1 hour. If I keep this as 9, we don't know how many hours this is going to go on for, so I'm just going to put a T right there. Now that's both equations that I need. It says that it wants a graph. Fair enough, we can put a graph on there, and then the graph is going to help us to find how tall they are after 3 hours. So you're welcome to do this by hand. You're welcome to just plug in multiple values if you want. But for me, I'm going to use a calculator. So on the top left, I push y equals, and then I put in both equations separately. So for me, y1 is 33 minus 6t. And then I go down to y2, and I put in 45 minus, well, it's not t, it's now 9x. So don't use t's, use x's, but it is a t button. Just one button to the right of alpha, the green button in the top left. Okay, so I have both of those in. And what I would like, because I'm going to have to put this graph in by hand, I'm going to use a table. So this is the table that the calculator shows me. Okay, so the table kind of starts like this. And I've got the values 0 through 6. So 1, 2, 3, 4, 5, 6. And then it gives me, I'm going to start with the y1 values, which is the equation. It's the values that I get from the A equation, Snowman A. So here are the values. All right, these are the values I have from Snowman A. So I'm keeping this in red, trying to color code things. And I can put these values, these are ordered pairs, right? I got 0, 33, 127, 221, 315, 4953. I cannot put 6, -3 because I wouldn't expect the snowman to be -3 inches tall. So I only want the positive values for my y's. But I can put these on. So I'm going to start with 0, 33, which I have right here. And we got 127. Found it. Then 221. 315. 49. And 53. Now before I connect these with the line, which I will do, and I will connect the line because this is a continuous function. Let's look at the ordered pairs for y2, which is actually the ordered pairs for b. So on my calculator, again, this was already showing for me. but I have these values. So these are the values that I see on my calculator. Now in purple, that's ordered pairs. So the first one there, 0.45, I can put that onto my graph. So 0.45 here in purple. I'm trying to color code the two lines. Then I have 136 here, 227 here, 318, and then 49. Now I've got a purple point and a red point in the same position. That on the graph would tell you that they're the same height at that time, which would be 4 hours after, I guess, sunrise. And then the last one I can put on the graph is 50, which is an x-intercept. And again, we can't go into the negatives. So pretty much this row in the table, we can't have it because we can't have negative values for a height. So now that I have these, I'm ready to draw the lines. Now, even before that though, remember over here it says, find the height of the snowman after 3 hours. Well, we have that in two different formats. You got this format in the graph right there, that's 3 hours. And then you can just follow this line up and it will show you the two heights. So height A right there, let's see if I can put this on there as an ordered pair, is showing at after 3 hours, it's 15 inches tall. That's snowman A, and then snowman B, it's showing that after 3 hours, it's 18 inches tall. Which, if you noticed in the table, it also gave us the same values. 3 for X is 3 hours after it starts, so that's this row right here. So you could have figured it out with the table, you could have figured it out with the graph, doesn't matter because the calculator did all the work for us, and that's what I like. Now that I have that, now I'm gonna go ahead and put these lines on the graph. So we'll use some technology, because my lines suck when I do it by hand on a iPad. There we go. And again, I'll just point this out again. This point right here, this one, where you have an X, you have a red and a purple point on the same location. That's when the two snowmen would have been the same height. So after 4 hours, they would have had the same height of 9 inches. But also, we don't care about that because that's not what it asked for. So let's see, which snowman is taller after 3 hours? Well, that is snowman B. There's our objective. Then I can solve systems of equations with any method. Elimination, graphing, and substitution. There we go.